Good afternoon, good evening. It's your boy Mr. Malachi, and in this video, I wanted to go through quadratic patterns. We're gonna go through firstly, how do we find the general equation of these? How do we use the general equation to find the 50th term, and how do we use the general equation to actually find the position that a term is in? So what is a quadratic pattern? A quadratic pattern is a pattern that is categorized by having a second line constant difference. So this one has a second line constant difference. So that is the definition of a quadratic pattern. And what does that mean? It means if I had a pattern, I'm not going to use values right now. It means if I were trying to find the difference between the second guy with the third guy, I would get a value there. And now the difference between the third guy and the second guy, I would get a value there. But the fact that this value here and the value there are not the same means that it is obviously not an arithmetic pattern. Then I would also need to find the value from this guy going to this guy, and the fact that that guy would be a constant number even to the next guy, that would categorize this as a quadratic pattern. But if you don't get it now, it's fine. I will actually look at values and we will expand that a little bit more a bit later in the video. So before we start answering questions, these are the three equations that you need to be familiar with. The first one says that 2a, and where is this a? This a is the same a that we have there in the equation. 2 times the a is equal to the first number in the second difference. So t1 in the second difference, that's the first term in the second difference. So that's the one we use to solve for a. Then the second one here, we use that to solve for b, this b that we see there. And that's the b that we're going to substitute there. And to find that, we say 3a plus the b is equal to t1 in the first difference. So the first term in the first difference. That's how you solve for b. And lastly, to solve for the c there, which is the same as the c there, you use this last equation that says a plus b plus c is going to give me term 1 of the pattern, the first term of the pattern. And the order at which we solve these, which is very important, is that we solve this first, we solve this one second, and this will be our last equation that we solve last. And again, these equations here are not given in your test and exams in the formula sheets, so you do need to memorize those, remember them. Some textbooks do actually take you through how those equations were derived. That's not what I'm going to do in this video, but yeah, you can check that out, and yeah, it should show you where these equations come from. But the biggest thing is remembering them, because you're going to have to use them. All right, let's jump right into a question. We're given this pattern here, and the first question actually asks us to show that this is a quadratic pattern. So let's take our pattern, a 6, a 17, a 34, and a 57. So to move from the 6 to the 17, I am adding an 11. To move from the 17 to the 37, to the 34, sorry, I am adding 17. And how am I getting these values? I just take the 34, I subtract the 17, and this will give me the 17 underneath. Again, 57 minus 34, and that should give you, I think it's a 23. Yes, it's a 23. Let me just double check. Minus 34. Yes, it's a 23. So we get those guys there. And since these are not constant, since these numbers are not the same number, that's how we know that it's definitely not a linear pattern. It is definitely not an arithmetic pattern. So let's find the second difference. So this line is called the first difference. And the next line that I'm going to do is called the second difference. Again, I'm taking the 17, I'm subtracting the 11, and I'll get that I need a 6. I need to add a 6 there to get to 17. Then from 17 to 23, I also need to add a 6. And there we go. The fact that this is a 6 there, and the fact that this is a 6 here, and the fact that this is my second difference, the fact that this number is constant, it's the same there, this proves that this is an this proves that this is a quadratic pattern. So that's how you answer the first question. Show that the fact that there is a constant second line difference. All right, then B, write the next two terms of the pattern. So let me just rewrite. Oh, actually, I can just complete this guy. Let me just erase some of these guys here. So since I'm adding a 6, this 6 will be the same. So I will be adding the same 6. So 23 plus a 6 would be 27. And so 57 plus 27 would give me 57 plus 27 is an 84. And I'm adding another 6. So 27 plus 6, you add a 3, that's a 33. And a 33, or rather 84 plus the 33 would give me 117. So to answer B, the next two terms of the pattern is an 84 and a 117. All right, we've answered that. Then C then says, determine the nth term as well as the 100th term of the pattern. So to get our nth term, we need this formula here. This is what they mean by the nth term, the general formula. But in that general formula, we need to find what the A is, the B is, and the C is. And once I found those guys, I can just substitute into that formula. So remember those three formulas I showed you? The 2A is equal to term number 1 of second diff. So what is term number 1 of second diff? It's this positive 6 here. So 2A is actually equal to positive 6. And if I divide by 2 and I divide by 2, so A is equal to a positive 3. I've solved for the A. Then the next formula is a 3A plus a B is going to give me term number 1 of first diff. And what is term number 1 of first diff? It's this 11 that we have there. So we're going to say 3, and we're going to substitute the A that we already found, which is 3. And in this formula, remember, we're trying to solve for B, and this is equal to 11. And so B is equal to an 11 minus a 9, and B is equal to a 2. And there we go. So now that I have my B, one last thing I need to solve is the C. And the C, you solve it using this guy, this last formula. And this says A plus B plus C is going to give me term number 1 of the pattern. Term number 1 of the pattern is the 6 there. So let me substitute the A I found, which is a 3. Substitute the B I found, which is this 2. And the C is the one I'm trying to solve for. And it's all equal to 6. And so C is equal to 6 minus a 5. And this would give me a C that is equal to 1. So what does that mean? Therefore, my actual nth term is a 3n squared, substituted the a, plus the 2n, I substituted the b, plus the 1 from the c. And this is your general formula, also called the nth term of the pattern. So now we have the nth term, we can use it to find T100. How does that work? We go where n is and we substitute 100 wherever we see n. And this guy, we just plug it into our calculator. And what you should get is 30,201. So what does that mean? In the position, in the 100th position, the term that I'll find there is this number here, 30,201. So we've answered C, and D then says which term will be equal to 162. So how do you do that? You take your pattern again, which is 3n squared plus 2n plus 1. But this time, you're not substituting for n. You're substituting for tn. The tn is given, which is 162. So it goes there. 162, 3n squared plus 2n plus 1. The 162 will go to the other side and subtract 3n squared plus 2n plus the 1 minus the 162. And in this case, 3n squared plus 2n. And if you subtract that, that is 161. So that is a quadratic equation that we need to solve. We can't solve it using factorization. We need to use the quadratic formula. There is our A, there is our B there, and there is our C. So now that we have those guys, we can easily just substitute into this formula here, the quadratic formula. And if I substitute, I'm just going to substitute this side, guys. Hope you can follow. X is equal to -2 plus minus the root of 2 squared minus 4, the 3, and then negative 161, all divided by 2, 3. And if we plug this into our calculator, we should get 2x values. But remember, we are solving for n's. I need to remember to write this as an n. And n. So yeah, let's plug it in and let's see what we get. All right, I get two n values. The first one is 7. And then if I go and change the sign on my root, next to my root, into a negative, I get the next one being negative 7.67. So this clearly cannot be a position. You cannot get a decimal position and you can't get a negative position. So I need to reject this guy and say n cannot be equal to that guy. And so the correct answer will be just 7. So what does this mean? Therefore, 162 is the 7th term of the pattern. All right, so that's it with quadratic patterns. I hope this makes sense. On that note, I will see you in the next video. Bye.